In this education tutorial, we're going to address SD-WAN. We will look at the drivers for SD-WAN and the problems with the traditional WAN. SD-WAN is mainstream now, and there's important reasons why its popularity has grown so fast. We really want to move away from running routing protocols at the WAN edge. We will also look at the standard features of SD-WAN, for example, the ability to create topology on the fly to suit your different application requirements. Until SD-WAN, the wide area network had enjoyed little innovation compared to other parts of the infrastructure. The changes to the application have been overwhelming with containers and microservices, but the WAN really only had Cisco performance routing and DMVPN. Now, DMVPN is a great technology, but it's not the easiest to get up and running, and also to troubleshoot. It has many moving parts that you need to be concerned with. Now, SD-WAN also has many moving parts, but all this complexity is abstracted away from you. So we really want the WAN to be more agile and fine-tuned for the cloud and the virtual world. You could say that the WAN is the last bastion of hardware modules in a network. However, it's one of the most critical and essential strategic points. So SD-WAN came out of necessity. And it's not that routing protocols such as BGP at the WAN edge were wrong. We just needed something more flexible for most application types. So the first significant issue is that we had a defined network topology if you had BGP at the WAN edge connecting to your other sites. An architect will design this network for you, and the applications have to fit this network design. For example, if we had a design where all traffic that go to the central data center for a security screen, even though direct from the branch site to the cloud or the internet, would have been a better design for that application. The fact being is that the network design was set in stone. Only some application types need to go back to the central hub. If you have a Cisco SD-WAN, you can have well integrated security at the branch site, such as enterprise firewall, URL filtering, or even combine your Cisco SD-WAN with Cisco Umbrella for DNS layer protection. So with this, it's safe for the branch to go directly to the internet or cloud without going back to the hub site for security screening. It was also challenging to steer traffic. Let me add the word dynamically steer traffic here. We could have one application going down one path and then another application going down one path, and that's pretty easy to set up. But what if you want to steer traffic dynamically and steer this traffic based on performance metrics? You would need to carry out some box-by-box configuration for this. So we can do this with BFD and IPsec tunnels. But it's better to have this centrally configurable, so you don't need to carry out any box-by-box configuration. Also, what about detecting brownouts? Now, blackouts are easy to detect. They're either up or down, but a brownout is a different type of failure and means different things to various applications. So we know that voice traffic is sensitive to latency and jitter. So if there is a brownout, we want this traffic to move to a better path as soon as possible. So SD-WAN allows you to overcome many of these challenges that will improve application performance. First of all, we can combine transports on the fly and specify what applications go over what transport, and if there is an issue, we can dynamically steer the traffic. We have a central location where we can perform all of the configuration, so we don't need to carry out any box-by-box maintenance. And in the world of SD-WAN, we have a management plane called the Cisco vManage where you configure all of your WAN edge devices. So now we can dynamically steer traffic really easy. So once again with SD-WAN, the WAN edge devices pair directly with the vSmart controllers with an enhanced protocol called OMP. And this tells them about the WAN fabric along with any policies that they should have. So now we can have different topologies and policies for each application. So not all applications will have the same network topology. So we will have virtual WANs which operate over an overlay network. So as it's an overlay network, it's logical and it's going to be easy to make changes to. So we can have many virtual WANs mapping to many virtual topologies. Around 5 should do it, but we can create more if we want to, and we can do this all on the fly when new applications come online. So in this quick education tutorial, we addressed SD-WAN. We looked at the drivers for SD-WAN and why we need it. SD-WAN is now mainstream and there are important reasons why its popularity has grown so fast. We really want to move away from running routed protocols at the WAN edge. We also looked at the common SD-WAN features such as the ability to create topologies on the fly to suit your different application requirements.